Hello my friends and welcome back to our Siemens Semantic Manager training course. Today we continue our introduction to the S7 300 and S7 400 PLC series. I would also like to remind you that this course is mainly a practical course, and together we directly inside the software we will study the PLC programming, internal memory structure, memory organization and PLC addressing. But before we begin programming, we first need to become more familiar with the PLC hardware itself, memory structure and the addressing system using the schematic PLC. So let's continue our lesson. And my friends, the input-output system of the Siemens S7 300 and S7 400 series consists of local input-output and the distributed input-output modules. It's a remote station and field device connected through the Profibus DP or AC interface. AS interface, and main point is that the PLC with the CPU 313 and 14 and higher can support up to 32 modules. This system can include the central rack, this one, and up to 3 expansion rack, 1, 2, 3. And in the picture you can see the distance between this expansion rack is up to 10 meters. Now my friends, let's talk a little more about the schematic S7 400. I also understand that the practice is more important, but before we continue programming, we first need to become familiar with the theoretical part. And the S7 400 is a modular PLC designed for medium and high complexity automation system. And the main component is the same like the S7 300, and also the S7 400 may have up to 4 CPU used in one system, which we cannot apply in the S7 300. Yes, like this. And also I want to talk about the battery system. Power supply in S7 400 can use 1 or 2 backup battery. Battery are optional if the program is stored in the ROM, but when the battery are installed, RAM data is preserved during power failure. And RAM data consists of the program flags, timers and dynamic data, and CPU real time clock continue working. And important thing, if one battery became empty, the system switched to second battery, and you will see the I can see it here. Yes, you will see the indicate battery failure or missing battery. It's a battery 1 fault or battery second fault. And important rule: battery must be replaced only when the power is on, and backup time of the battery, it's the 2 batteries can keep CPU memory buffered for the about 1 or 2 years without external power. And my friends, PCS7 400H in the last word of serious number is a fault tolerant the PLC system designed for critical application where the failure can cause the danger to human life, large production losses or environment damage. The main idea is the system use two PLC and they are connected using the fiber optic links, this one, and the operation principle of the system is the CPUs work in master and standby mode. One CPU is active, the second CPU is running in hot standby mode. Also we can say it's the hot redundantly mode. If the main CPU is failed, the backup CPU automatically take the control without stopping the process. And the simple analogy, it's like you have two main pilots and the second pilot ready to immediately take control if there's something happened. So my friends, in the next lesson we will start to talk about the addressing, and after addressing I think we start to closely work with semantic managers. And my friends, if you don't have the semantic managers and you want to install this program, or if you cannot install this program to your computer, you can write to our web page, and our engineer is provide you with a virtual machine, and you can use the program online from your phone, from your tablet, or from your PC. So my friends, that's all for today. I wish you good health and good life. Don't forget to subscribe to our channel and hit the like button if you enjoyed the video. See you in the next lesson.